Hello, algebra students. Mr. Lawrence here, and today we are going to work on factoring trinomials using the grouping method. Now, I got to tell you, I didn't ever used to teach it this way until recently, meaning last year, and I think this is the best way to do this. It is so simple. All right, so watch how we're going to do this. We're going to take a trinomial. Remember the trinomials because they have three terms. Uh-oh, I got airliner activity acting up here. Okay, not sure what's going on. Hold on one second. My airliner is acting very strange. I think that means the battery is going dead, so I plugged it in. Anyway, yeah, it's working a little bit better now. Okay, let's see here. My calligraphic pen is missing. Okay, that's all right. The first thing I'm going to do is I'm going to look at the lead coefficient, which is 1. And by the way, all these will have a 1 today. The next video will talk about how to handle it when it doesn't have a 1. These should be really simple. I'm going to multiply the lead coefficient, the 1, by the constant, the 12. And I always have them written in descending order, x squared, x to the first. And then if you wanted, you could call that x to the 0. It'd be a waste of time, but it is true. It is x to the 0. Okay, so we're going to multiply the 1 times the 12. Okay, and of course we're going to get 12. And then what I'm going to do is I'm going to list the factors of 12. Okay, now if they get really big here, this isn't the best way to do it. We can work smarter, not hard, but for right now it's going to work really well. Okay, because the 12 is positive, I am going to look for two factors of 12 that add to get this number, positive 7. Well, that would be 3 plus 4, right? Now watch what I can do. I can rewrite my trinomial as a polynomial with 4 terms, x squared. I'm not going to write 7x. I'm going to write plus 3x plus 4x. So I'm breaking that 7x down into two of its add-ins, two numbers that add up to get it. How do I know which numbers to use? Well, I'm limited by the factors of 12. Where did I get 12 from? By multiplying the lead coefficient of 1 times the constant 12. Okay, 2 plus 6 doesn't make 7. Can't use those. 1 plus 12 doesn't make 7. I can't use those. Now that I have this problem like this, I can go ahead and group. So I'm going to group my terms like this, put a plus sign in the middle. Looks like my GCF here is going to be an x. I will factor out an x, leaving me with an x plus 3 in this quantity. Here the GCF is a 4. We're going to factor out a 4, leaving me with an x plus 3 as the quantity. Got one more GCF to do. Going to pull out that x plus 3 as my common factor, and I'll be left with an x plus 4, and there you go. Now, if you have older brothers or sisters or parents who are good at math, they're going to say, I know a different way, an easier way. Maybe so, but when this lead coefficient isn't 1 anymore, it gets a little more difficult. Instead of teaching you a bunch of different ways to do it, I'm going to teach one way. If you understand the way somebody else shows you, you do it well, I don't mind at all. You go ahead and do that. Okay, let's look at another example. Number 2, the lead coefficient is 1. I can't seem to get in the right spot here to draw. There we go. I'm going to multiply the 1 times the 6. I'm not going to worry about the negative right now. I'm just going to do 1 times 6. And 1 times 6 will be 6, of course. I need the factors of 6. This time, though, the 6 is negative, right? So I don't want to add 2 factors of 6. I want to subtract 2 factors of 6. That will get me a negative 1. Well, I think that's going to be 2 minus 3, right? So I'm going to rewrite this trinomial as a polynomial with 4 terms. I'm going to write it as x squared plus 2x minus 3x minus 6. All right, now I'm going to group. Remember, I always have to sneak that plus sign in between there, otherwise I've changed the problem. Okay, I'm going to pull out my GCF, and that's going to be an x. Going to be left with an x plus 2 in the quantity. Here, I'm going to pull out a negative 3, and I'll have an x plus 2. I'll factor out the GCF of x plus 2. I'll be left with an x minus 3, and there you go, it's factored. If I FOIL this, I'll get x squared minus x minus 6. If I FOIL the purple one, I will get Something is weird. Look at that thing go. Um, I will get x squared plus 7x plus 12. All right, number 3. I'm going to multiply the 1 times the 18. I need 2 factors of 18 that subtract to get positive 7. Well, I think that's going to be 9 minus 2. So I rewrite this trinomial as a polynomial with 4 terms. Some of you are thinking, Mr. Lawrence, could I have written minus 2x plus 9x? Does it equal positive 7x? If it does, you can rewrite it that way. Okay, going to do my grouping now. I've got 4 terms. Going to stick a plus in the middle. My GCF is going to be an x. I'll be left with an x plus 9. My GCF in the second quantity, I'm actually going to pull out a negative 2 and leave me with an x plus 9. One more step, I'm going to have an x plus 9 and an x minus 2. And there you go. Pretty easy stuff. Okay, I'm going to do 2 more examples. Here, I'm going to need 2 factors of 18. They're going to add to get negative 11, right? So, hey, you know what? Right off the top of my head, I know I have 18. I know 2 factors of 18 that can make 11, 9 and 2. But I need negative 11. Well, what if they were both negative? So I'm going to rewrite this as x squared. And I think I'm going to put the minus 2x first, the minus 9x next, plus 18. Because I'm drawn kind of like Jordan to the 9 and the 18 kind of stand out to me. Okay, now I'm ready to group. So I'm going to group first pair, group the second pair, put my plus sign between. Okay, pull out the x. I'm going to pull out a negative 9. Somebody's probably wondering why I pull out a negative 9. Well, if I don't, I'm going to get a negative x plus 2. Both signs are incorrect. I'll pull out a negative 9. All right, x minus 2 is common to both parts. X minus 9, and there you go. Okay, I just have one more example I want to do, and that will be this one here. Notice there's no x term. There's actually 0 x's in the problem. There's an x squared term. The last term is 16, the constant, negative 16, but there are no 0, right? There's no x's. There's not a 5x in the middle. Put my little 1 in there. Okay, so I'm still going to multiply the 1 times the 16. I'm going to need 2 factors of 16 that subtract to get 0. Well, hey, how about 4 minus 4? So I'm going to rewrite this as x squared plus 4x minus 4x minus 16. Yeah, that would give me 0, wouldn't it? Plus 4 and a minus 4. Now I'm ready to group. Put these together, put those together, stick that addition sign in between, pull out my GCF. Oops. X times the quantity of x plus 4. 4 looks like the GCF, but both signs are negative. I want both signs to be positive. I'll pull out a negative 4. X plus 4. Yeah, I pull out an x plus 4, pull out an x minus, or x minus 4 is left, and there we go. And if I FOIL that, you should notice that your inners will get 4x and your outers get minus 4x, and they would cancel, leaving you with x squared minus 16. All right, that's it. That's all we're doing. This should be pretty easy. And if you're any good at the algebra we're doing, I don't know about you, but I think factoring is really cool. I feel really smart when I do it because it's pretty neat how I can take these things apart. All right, that's it for the video. Mr. Lawrence signing off. Have a good night, everybody. Hey.